Assalamualaikum warahmatullahi and hi. Today we continue our lesson for topic 1, differentiation. Now we discuss lecture 4 of 6, rules of differentiation. At the end of the lesson, students should be able to apply the rules of differentiation. Number 5, chain rule for y equal to fu where u equal to gu. Then dy dx equal to dy du times du dx. Number 6 is general power rules for y equal to fx to the power of n. Then dy dx is equal to n times fx to the power of n minus 1 times f prime x. And B, perform second order differentiation. Rules of differentiation. The chain rule. If y equal to fu is a differentiable function of u and u equal to gx is a differentiable function of x, therefore if y equal to f gx is a differentiable function of x, then dy dx is equal to dy du times du dx. Or equivalently, differentiate f gx with respect to x is equal to f prime gx times g prime x. For example 1, find dy dx if y equal to u squared minus 3u plus 1 and u equal to x squared plus 2. We solve this question by using the chain rule. Now, we write y equal to u squared minus 3u plus 1. Now, we differentiate y with respect to u. dy du equal to 2u minus 3. And when u equal to x squared plus 2, we differentiate u with respect to x. Du dx is equal to 2x. Therefore, dy dx is equal to dy du times du dx. Now, we write 2u minus 3 times 2x. 2x times 2u minus 3. Now, 2x times, we substitute u is x squared plus 2. 2 times x squared plus 2 minus 3. And we simplify in bracket 2x times 2x squared plus 4 minus 3 is equal to 2x times 2x squared plus 1. In general, any composite function of the form y equal to fx to the power of n involving some function fx raised to a rational power n is called the general power rule. It is a special case of the chain rule. Now, let y equal to u to the power of n where u equal to fx, then dy du is equal to n times u to the power of n minus 1. And du dx is equal to f prime x. Using the chain rule, dy dx is equal to dy du times du dx. So, dy dx is equal to n times u to the power of n minus 1 times f prime x. Then substitute u equal to fx. Therefore, for general power rule, differentiate fx to the power of n with respect to x is equal to n times fx to the power of n minus 1 times f prime x. For example 2, given y equal to 2x power 4 minus 9x plus 6 to the power of 4. To solve this question by using the general power rule, you write dy dx equal to the power is 4. So 4 times 2x power 4 minus 9x plus 6. The power is 4 minus 1 time, in bracket, we differentiate 2x power 4 is 8x cubed minus differentiate 9x is 9. And we can write 4 times 8x cubed minus 9 times 2x power 4 minus 9x plus 6 power 3. Next, example B, given y equal to 2 over 3x squared minus 1 power half. We can write y equal to 2 times 3x squared minus 1 power negative 1 over 2. Next, differentiate y with respect to x. dy dx is equal to 2 times the power is negative 1 over 2. Time in bracket 3x squared minus 1, the power is negative 1 over 2 minus 1 times differentiate 3x squared is 6x. Now we can simplify. 2 times negative 1 over 2 is negative 1 times 6x times 3x squared minus 1 power negative 3 over 2. Next, we have negative 6x times 3x squared minus 1 power negative 3 over 2. Or we can write negative 6x over 3x squared minus 1 power 3 over 2. For example 3, given y equal to x plus 1 squared times 1 minus 3x squared. We solve this question by using the product rule and the general power rule. So, dy dx is equal to, the product rule is u v prime plus v u prime. Now, we write u equal to x plus 1 squared. So, differentiate u prime equal to 2 times x plus 1. Then, v equal to 1 minus 3x squared. Differentiate v prime equal to negative 6x. Therefore, dy dx is equal to u x plus 1 squared times v prime is negative 6x plus v is 1 minus 3x squared times u prime is 2 times x plus 1. We cross. Then we can simplify negative 6x times x plus 1 squared plus 2 times x plus 1 times 1 minus 3x squared. Now consider x plus 1 squared and x plus 1. So we can factorize x plus 1. We have x plus 1 times first negative 6x times x plus 1, and the second term is 2 times 1 minus 3x squared. Next, we simplify the cube bracket. We have x plus 1 times negative 6x squared minus 6x plus 2 minus 6x squared. And we have x plus 1 times negative 12x squared minus 6x plus 2. And we can factorize the second bracket. We factorize negative 2. We have negative 2 times x plus 1 times 6x squared plus 3x minus 1. For example 3b, given y equal to 3x squared times 7 plus 2x cubed. We solve this question by using the general form and the product rule. The product rule is dy dx equal to u v prime plus v u prime. Alright, u is the first term, 3x squared, differentiate u or u prime equal to 6x. And v, the second term, is 7 plus 2x cubed. Differentiate v or v prime equal to, the power is 3 times 7 plus 2x. The power 3 minus 1 is 2. Time in bracket, differentiate 2x is 2. And we write 6 times 7 plus 2x squared. Now we cross multiply. We have u is 3x squared times u prime 6 times 7 plus 2x squared plus v is 7 plus 2x cubed times u prime is 6x. We write 18x squared times 7 plus 2x squared plus 6x times 7 plus 2x cubed. Now we have two the same factor, 7 plus 2x squared and 7 plus 2x cubed. Now we try to factorize 7 plus 2x squared. 7 plus 2x squared, and the first term is 18x squared and the second term is 6x times 7 plus 2x. And we try to simplify in the cube bracket. We have 7 plus 2x squared times 18x squared plus 42x plus 12x squared. And then 7 plus 2x squared times 30x squared, 30x squared plus 42x. And we can factorize. We compare 30x squared and 42x. We will write 7 plus 2x squared and factorize 6x. And we have 5x plus 7. And the final answer is 6x times 5x plus 7 times 7 plus 2x squared. For example 3c, given fx equal to x minus 3 squared divided by 4 plus 3x. We solve this question to find f prime x by using the quotient rule. So, f prime x equal to v u prime minus u v prime over v squared. V is the denominator and u is a numerator. So, v equal to 4 plus 3x and v prime equal to 3. And u is equal to x minus 3 squared and u prime equal to 2 times x minus 3. Now we substitute. V is 4 plus 3x times u prime times 2x minus 3 minus u x minus 3 squared times v prime is 3. Divide by v squared. 4 plus 3x squared. Now, at the numerator, we compare the same factor, x minus 3. So, we can factorize x minus 3. So, we have 2 times 4 plus 3x minus x minus 3 times 3. Divide by 4 plus 3x squared. Then we can simplify in the cube bracket. We have x minus 3 times 8 plus 6x minus 3x plus 9. Divide by 4 plus 3x squared. So, we have x minus 3 times 3x plus 17 divided by 4 plus 3x squared. Next, consider the function y equal to fx. Differentiate y with respect to x. The first derivative of f, that dy dx, is equal to f prime x. Then, differentiate dy dx with respect to x again. The second derivative of y, that is, differentiate dy dx with respect to x. And we can write d2y dx squared, or f double prime x. First derivative, we can write y prime, or f double prime x, or dy dx, or differentiate fx with respect to x. Then, for second derivative, we can write y double prime, or f double prime x, or differentiate dy dx with respect to x again, or we can write d2y dx squared, or d2 fx differentiate again with respect to x. For example 4b, find the first and the second order derivative of y equal to negative 2x power 4 plus 9x cubed minus 5x squared plus 7. For first derivative, dy dx equal to negative 8x cubed plus 27x squared minus 10x. Next, for second derivative, we write d2y dx squared and differentiate again with respect to x. We have negative 24x squared plus 54x minus 10. And for question B, given fx equal to 5 times 3x plus 1 power 6. First derivative, we write f prime x equal to 5 times 6 is 30 times 3x plus 1 power 5. Time differentiate 3x is 3. So, we have 90 times 3x plus 1 power 5. And for the second derivative, we write f double prime x. We have 90 times 5 is 450 times 3x plus 1 power 4 times 3. So, 450 times 3 is 1350 times 3x plus 1 power 4. For example, 4c, given y equal to 4x minus 1 divided by x squared. The question is, find dy dx and d2y dx squared. First, find dy dx by using the quotient rule. So, we write v equal to x squared, v prime is equal to 2x, and u equal to 4x minus 1 and u prime equal to 4. Now, to find dy dx, v times u prime minus u times v prime divided by v squared. So, we have x squared times 4 minus u 4x minus 1 times 2x divided by x squared and squared. So, we can simplify 4x squared minus 8x squared plus 2x divided by x power 4. And we have negative 4x squared plus 2x divided by x power 4. We can factorize negative 2x. So, we have 2x minus 1 divided by x power 4. And we can simplify negative 2 times 2x minus 1 over x cubed. To differentiate for the second derivative d2y dx squared, we can follow from dy dx. Now we try to differentiate again with respect to x. We write d2y dx squared using the quotient rule. By using the quotient rule, v times u prime minus u times v prime over v squared. We write v is denominator x cubed, v prime is equal to 3x squared, and u, the numerator, negative 2 times 2x minus 1. Differentiate u or u prime, negative 2 times differentiate 2x is 2. We have negative 4. Now, by using the quotient rule, we have x cubed times u prime negative 4 minus u negative 2 times 2x minus 1 times v prime is 3x squared divided by v squared x cubed squared. And we can simplify negative 4x cubed plus 6x squared times 2x minus 1 divided by x power 6. And we try to simplify negative 4x cubed plus 12x cubed minus 6x squared divided by x power 6. And we have 8x cubed minus 6x squared divided by x power 6. And we can factorize 2x squared. So we have 4x minus 3 divided by x power 6. And we can simplify. We have 2 times 4x minus 3 divided by x power 4. For example 5, given y equal to ax squared plus b over x, and show that x squared times d2y dx squared equal to 2y. For this question, we use the second derivative. First, when y equal to ax squared plus bx power negative 1, to find dy dx is equal to 2ax minus bx power negative 2. And differentiate again with respect to x, we write d2y dx squared is equal to 2a plus 2b times x power negative 3. Or we can write 2a plus 2b over x cubed. We write in the same denominator. So we have x cubed times 2ax cubed plus 2b. Now, to show that we have left hand side is equal to right hand side, we can show that the left hand side is equal to right hand side. X squared times d2y dx squared is 2ax cubed plus 2b divided by x cubed. And we can simplify, we have x. Therefore, 2ax cubed plus 2b over x. And we can separate, we have 2ax squared plus 2b over x. And we factorize 2, we have ax squared plus b over x. The cube bracket is y equal to 2y. Shown. That's all for lecture 4 of 6. Consistent study and understand the concept. There are no shortcuts in the mastering maths. Try your best. Thank you.